Hello, CB community across the nation and abroad. This is Eagle One, the infamous Keydown King, and you are tuning into Gatekeeper Amps. Break.
Alrighty, Mr. Gatekeeper here. We got ourselves a nice little Texas Star DX500V that I believe a ham operator will be using, because one of the major things they want done is to make sure to get this thing retuned for 28.4 megahertz. And we've got a pretty decent list of things that needs to be attended to. This box will sit down by the godfather of amps, Mr. Alpha Mike Power. Alrighty, let's dig in, man. Oh, got a couple things. One of the bearable deleted. Wants the SSB switch just to be on at all times. Basically, there's no need to turn the SSB delay on and all that good stuff. So technically, wants it to be converted to a 500, a DX500 HDV is what it is now. So he wants it converted over to basically a 500 HD. So let's dig in. That's what I was working on. Oh, one thing I do want to note, I don't know if this was done during shipping or not, but we will do our best to get that bent back. And it's already been worked on a little bit, so I think there's some transistors removed. I can see there's a power wire upgrade that's been done. We'll make sure to connect them together real well. What kind of power wire is this? Stinger. Pretty good power wire. I've been kind of curious to see what Stinger looks like next to my new concepts I use. I'll have to do that here in a little bit. Alright, let's dig in. Alright, first things first. I'm going to go ahead and remove all the coaxes we're going to be replacing. Went ahead and removed the other 330s. He sent us 4 matching DM19 330s. He says they're matching, and guess what? I checked them, and they are matching. They are matching. Went ahead and remove these. If you'll notice, whoever did this power wire upgrade, there's no extra beads on the power wire. So what we're going to do to help just mitigate that, put a little bit more inductance on the power wires. We're going to roll with a 4-wrap 14 gauge feed in the back of the transformers, and that will be replacing this, which will help a little bit less voltage drop. Also will help a little bit less heat, help get a little bit more current to those transistors. I checked these two that was removed. They're good. One's an 18, one's a 20 HFE. Kind of wondering why they were removed. I'm kind of wondering if there may be some hidden issues going on. I didn't really read anything in the. I didn't really read anything in the notes. Basically, what was wrong with it, beforehand for them to be removed. So we're basically just going to put this thing back together. We're going to make the coaxes up, put this thing back together as it is first. I did go ahead and do my little soldering on the grounds right there and thickened up this output trace like I always like to do. This is an older box. This is an older box. I had to put some good heat. I had to put some decent heat on those, because over time, these right here can become oxidized, and it will cause a ground or a B plus voltage to not get for the lamps. That's just for the lamps right there. And I learned that a long time ago, man. I just, whenever I get these with the older switches, I'll just go ahead and just solder, because they're just leaning against the actual lead of the switch, and both of them can become oxidized just as, you know, time goes on and may not making a good connection. So I just solder them. All right, that is a unique variable. He wants that bypassed. Alrighty then. Alrighty then. So yeah, I went ahead and cleaned the box up. I don't know if I did a before after video or not. I think I did. So I went in here and cleaned this box up. My beautiful girlfriend actually helped me while I was going up. I hadn't cleaned all the flux up everywhere. I'll probably, well, for one thing, he didn't want me to do so much to the amp that it's going to cost a whole lot of money, which I understand. I'm so used to a lot of guys when they send me these amps, you know, they'll be like, work your magic, do whatever, do what you do. That's when I'll get in here and I'll clean every crevice of this amplifier. You can look in here and you won't see no flux anywhere. It'll just be a prestige clean amplifier, so clean on the inside that you can eat eggs off of it if you can warm it up. Warm this heat sink up good enough, put you some eggs right there, cook them up. Alright, well, let's get on with the show here. Yeah, let's get the coax made and get everything put back together, get these cut down, installed, drop those peels back in, and first thing we'll be doing is checking the bias. Whenever you see a Texas Star that's using a DM15 right here for the output tuning capacitor, that is an indication that it is an old amplifier, because all the newer ones are going to have a metal to ground. We'll be removing this and this to get it retuned for 10 meters for sure. A lot of the older Texas Stars are actually already tuned for 10. I bet y'all didn't know that, did you? They were actually truly 10-meter transmitters. CW transmitters. Alright, I'll be back. Alrighty. Oh, she is a-working. She is a-working. Now, a couple of things that was asked about on the paper. Want the SSB delay on at all times. So it is on at all times. There's no reason even to push this button. Now, one thing I wanted to do was to have this light come on as soon as you turn the power button on, just to indicate the SSB delay is on. But there's one small issue about that. Right here on this diagram I drew. This is the 1,000 microfarad capacitor with the delay, okay? The negative side of it goes on to the negative side of the relay. Positive side, watch this. Okay, it isn't hooked to this. The only time the way I draw my diagrams is hooked to something when there's a circle like this drawn, okay? Watch this. It connects to the positive side of the lamp, which connects to that common side of the switch, right? But look at this. Look at this. Texas Star connects it to the normally open on this side of the switch. And I have earthly no idea. That serves no purpose whatsoever. It serves absolutely no purpose. This side of this portion of the switch is for when the switch is pushed on, this common touches the normally open, which gives the ground for the lamp to come on. Okay? if you shorted this with this, so the lamp's on, when it's off, you got a dead short. There's no reason for this to even be here. Absolutely no reason. When this is in the off position, this is touching the normally open of this, okay, and of this, and of this, and of this. There's no reason for it. I have no earthly idea why Texas Star did this. Is it a mistake? You know, at one point I thought maybe that's a bleeder for the 1000, you know, when you turn everything off. Maybe that's a bleeder. It can't be a bleeder because it's not connected to ground. There's something magical here that I'm absolutely missing. And here's the problem. Let me show it to you on the actual board itself. Right here. This right here is that bridge right here. So it's on the top. So the only possible way for me to do that, to make that work, is I'd have to get up under here and cut the first pin right here, which ain't even used. You know, it's not used. It's absolutely not used. It's not used for nothing. No function of the amplifier. That portion right there is not used. This side of the switch is only used to give ground to the lamp. That's it. This normally open and this normally open. This part of the switch is absolutely not used. You could cut both of them and it wouldn't change no function of the amp. Period. But I wasn't going to go to all that trouble just to get the light on. I wasn't asked to. You know, I would if somebody asked me to do it. If they wanted to see that light on when they turn the power on and remind them that the SSB delay is on. I was about to do it, but I'm not going to be cutting on anybody's switches and stuff like that without their permission. Even though, you know, it serves no function. Still, us as guys that work on repair amplifiers, there is a certain limit you should go without talking to the person. That's a limit for me. Would be cool. Don't get me wrong, would be cool. This bad boy was blown. So we put in a more a better delay cat. A lot newer. Next thing I done, which was on the list, was you know, got the delay on at all times. Okay. Next was you wanted the variable removed. Okay, so we've got that removed. And the most easiest way possible, that's done. So no matter what you have pressed now, this box is going to do the same amount of power. Dude, we're on average now. Dude. Dude. So no matter what you press now, the same amount of power. Alright, so next thing I got to do, here's the problem. When you remove a variable like I was asked to do, this is a Texas Star 500V. The variable, just in case anybody didn't know, is the only thing that holds this faceplate on. It's the only thing. I mean, you can say, yeah, the variable, I mean the meter, yeah, it keeps it from coming off, but from keeping it tight and actually holding it on, it's the variable. So, how do you get around this? Well, the easiest way to get around this is just to replace it with a 500DX front, non-variable front, which I don't have for a change. It's been a little while since I can say I don't have something, but I used my last one up. I've got some 400s. I've got some other unique non-variable 4-pill, 5-pill non-variables. Then they use these right here to hold on. So that's what we're going to have to do. I'm going to unsolder this, remove this, remove the meter, and go ahead and install them so this thing can be put on. Then we'll put a plug right there. I really do wish I had a 500 HD, which is a non-variable version of the Texas Star, but I don't. It sucks, but I don't. I got the 400, got the 667, got the white line, got the Scorpion, but don't have that. So we're just going to have to plug it. I hate that. I love doing Texas Stars and keeping them completely OEM, so you can't even tell nobody worked on them, but on the outside, but it is what it is. So let's get all that done, and then next is time to tune. This is what it looks like on 11 meters. Ooh, yeah. Ain't too terrible. Ain't too shabby, but can be better. So we're going to get this thing and tune it for 10. Around 28.385 around, or 28.5 is the best place, right down in the middle of the foam band on 10 meters. But I'll do it to whatever frequency he put on the sheet. I'll look back and see. All right, we'll be back, y'all. Alrighty, Mr. Gatekeeper back here. We got this Texas Star 500 completely converted to 10 meters. Put us a little plug right here. We got the front mounted now. Put just a little bit of hot glue right here just to keep this right here, but if somebody ever needs to take it out, it'll be, you know, pretty easy to get this out and replace it in the future. You don't want to put no epoxy or nothing like that. Just want to put a little bit of hot glue so it can be easily removed. Maybe just heat it up after unsoldering these leads and pull it out after it's unbolted. Well, that's the front bolted, not the meter. But anyway, yeah, we had a couple of setbacks while doing this. As I mentioned, I quickly figured out that the SSB delay cap was blown, which wasn't quite showing us any issues on AM by no means. But once I went to sideband, or just turning it on sideband, I started noticing some issues there, and popped a key-in transistor. Actually popped 3 key-in transistors. The first time I'm like, maybe the key-in transistor, like this here, maybe the key-in transistor just gave up the old ghost. Let's put another one in. It pops instantly. I'm like, well, good God, what's causing this? Looking around, this and that, everything looks good. I'm doing all my trace points right here around this circuit. There's no dead shorts to ground. There's nothing touching ground. Everything is passing through. The capacitors are good, everything. So I'm like, maybe it's just a fluke. Maybe it's just a fluke and it's a bad transistor or something. Put in the third one. This time I'm looking around a little bit more, this and that. And I remember at this point I had the button pressed like that. That's what it was just still pressed for my testing. Unpressed it, keyed up a couple times. It's no problem whatsoever. I'm like, well, hold on though. Let me just make sure. Keyed it up. Yeah, I didn't mean to throw this in there yet. Keyed it up. There went that one. I'm like, okay, this has something to do with the SSB delay circuit. And that's when I started tracing everything, and I found out that the capacitor was blown. I removed it. As soon as I was removing it, you could smell it. That's one of the easiest ways to tell when a cap is gone. You can smell it, it's gone. And then once we did that, and the fourth, well, this is the older trend that was already in there, so 1, 2, the third transistor I put in was finally good. So always remember that, y'all. If this right here is blown, it can or it will take out your keying transistor for sure. So I think I've already showed this, but just to refresh my memory, I drew the diagram of the dial-a-watt and delay because the guy was wanting the delay on at all times. I've already explained this. I'm remembering now. This was like 2 days ago. I really wanted to have it to where this lamp stays on when you turn the power switch on, but because of this issue right here, I can't do that. Because if I connect these two leads together to where when you turn the power on, the lamp comes on, it's shorted. The ground shorts right here. So the only way to do this is for me to cut this pin right here. Let me show you which pin I'm talking about. Come on, man, you're supposed to be a best camera in the world. What's going on? That first pin that you see right there, that would need to be cut. And I wasn't about to do all that without permission and all that. So we just left it to where the SSB delay is on at all times. If you turn this on, it makes no difference. This right here has been took out. Makes no difference if this is pushed in. Nothing makes any difference if any of that is pushed in now. So that there's, and of course we removed the attenuating resistors. He wanted them to be removed, which was right here. Next, what we had to do was tune the amplifier at this frequency. At this frequency. Now, if this was a old Texas Star, a lot of them were already tuned on 10 meters. But this was not. This was a newer one. Well, it wasn't a new one. It was what I'd call medium, right there in the mid-age of everything. It wasn't a new Texas Star, but it wasn't a super old one. It was right there around the mid-age, where you'd see them go kind of off chart when you look at the regular schematics here. They would go off chart with a couple of things. Like, for example, this is supposed to be 2 wraps on the inputs, 4 on the outputs. Okay, this is a 500. 1200's on top, 1000's on the back. 120 right here. Wait, I meant to say 330 right here. 91 or 100 on the back. All that was wrong. We got 3 wraps on the inputs, not 2, and that's not the wrap for a 400 or a 500. It's just an in-between circuit that you'll see them do sometimes. So I had to get in here and just kind of go off normal schematic following, which keeps things easy. I just had to get in here and do some testing myself using my past experience and this and that, because before I just went all out and just straight converted this to an exact 500 the way it is, because the amp was working great the way it's built. It's working great. So there's no reason for me to go out and put 2 wraps on it. I wanted to see first, can I get this thing tuned on 10 meters? If I can't, then we're going to just switch this thing completely to where it's supposed to be, going by the schematic for a 500, even though this is working out just fine. So that'll start me back at a baseline and work my way up. So as soon as I hooked it up and went up there to 28.4, I had this much reflect right here. Almost 3 watts of input reflect. Oh my God. So another thing I saw that was pretty crazy, this is what's on there. And if you can see, 182, that means 18 with 2 zeros. These are 1800 picofarad caps. You do not find them on Texas Star 400s or 500s. You just don't. It's either going to be a 1200 or a 1500. You don't believe me? It's right there. .0015 is 1500. .0012 is 1200 UF. So that's when I'm like, okay. Went ahead and dropped the trimmer right here on the input, dropped my trimmer right there on the output, and I went ahead and first just try to see if I can get some tuning done without doing anything else. Nah, couldn't do much with it at all. So we went ahead and removed these two right here, which is what you see right there, and we just started easily working our way down from 1800 and got this bad boy tuned. As you'll see, I made me up a quick 316 jumper, which is what I've been needing to do because I didn't have a jumper for that radio handy. I think I'm gonna make me a video too, showing people how to do these, because you know it's a PL259 is a pretty big connector for a small wire like this. And I got a little cool way I do it that works out great. Here's your input reflect now. 500 watts off the Richter. This thing is tuned. Now the output had a 91 picofarad, and we were able to. It did not tune out to 91, of course, since we're on 28.4 megahertz now. Here's what happened. You go up in frequency. All right, this is when you learn about capacitance and inductance. You go up in frequency, either capacitance or inductance gets larger, go down. That's the way this stuff works, okay? I can't remember off the top of my head if you go up in frequency, the capacitance increases or not. But in this type of situation, the capacitance decreased as we went up in frequency for the input shunt caps, okay? I could just tell you the values, but I don't want you just sitting here copying this because it may not work for your setup. See, this works for this exact setup of the type of wraps and everything. The output lowered. It went lower than 91 picofarad. And the input went lower than where it was, which there was a 120 in there. It went lower. Not much lower, but lower than 120. Alright. Now let's take this 500 out and put 1,000 in. Alright, this radio right here is doing about 40 watts PEP. So that is about 680 watts peak. Yeah, I'd say about 680. Look at it a little closer. 650, 660. Because that line right there in between is going to be 700, as you can see. So, yeah. Yeah, about 650, I'd say. 650, 660. And the input reflect is very, very low. 5 watts low. Very low. Very low. So this thing is now ready for 10 meters. Ready to rock and roll out there. Doing some good contest on 10. Rag chewing on 10. Whatever you want to do on 10. This is the second Texas Star that I have converted to 10 meters for a guy. And I've actually got a 350 I'm going to be converting over to 10 meters for a fella. Now, these are considered wideband amplifiers. Yes, they are. They really are. 2 to 30 megahertz. but you can narrow band them in, meaning this amplifier would have worked for 10 the way it was, but from doing this, now it's going to work as best as it possibly can because it's been narrow banded to that frequency, and did a good job. I think I pretty much covered everything. He asked me to replace all the coax right here, which I've done, and since there was no beads on these, I could pull this out and add a few beads on this, but you ain't putting no bead on that power wire. What I'll do to kind of help mitigate that issue, just because, you know, that single bead don't do a whole lot. You know, it's considered a one turn in the RF world. This right here is 14 gauge wire with 4 wraps. So that adds a lot of attenuation in ohms on the frequency that we are, to help keep that RF, as much of that RF as possible, from going back this direction on the power wires. So there you go, the old gatekeeper, another Texas Star repaired and ready to go on the hand bands of 10 meters. Don't forget, y'all, the gatekeeper has love for both sides of the spectrum. And we're good and gone. 73. God bless. Bye-bye.